functions, we will be writing functions. And how will this take shape? Well, number 9, you're just going to, I guess, flat out write linear functions in a number of different ways. Learning target number 10, you're going to write equations for lines that are perpendicular or parallel to other lines, which is something you're probably familiar with. And then learning target 11, you're going to use graphs to solve some questions or some problems. So again, I'm hoping that a lot of this is review, or maybe just kind of like a little bit more challenging than the traditional way you saw it before, but I don't anticipate there being a whole lot of issues for you in this lesson. The two big things that you got to know for this particular lesson, when you have lines that are parallel, their slopes are the same. Okay, so if I had something like y equals 2/3 x plus 5 and y equals 2/3 x minus 1, I would know right off the bat that I just look at this number right here, the number in front of the x, and since both of those are the same, well, these are parallel. And even if I were to just do a quick sketch, I had 2/3 5, so up to the right 3, it looks something like this. And then if I had y-intercept at -1, but I had the same slope, up 2 over 3, well, they'd be parallel. Perpendicular slopes. Instead of being the same, when you got perpendicular lines, their slopes are going to be what's called the negative inverse of each other. And so the negative inverse, another way of saying this is the opposite reciprocal. So these are synonyms, means the same thing, but essentially here's how it goes. Like let's say I started with 2/3. We know that if I had another one with a slope of 2/3, it'd be parallel. But when it comes to perpendicular lines, negative means positive turns into negative. An inverse or reciprocal means I flip it upside down. So 2 over 3 becomes negative 3 over 2. So these two slopes would be perpendicular. Well, let's see, what happens if we had something like -4? What would be the negative inverse of that? Well, the opposite or negative of negative would be positive. And, well, this would be like 4 over 1. So if I do the inverse of that, or the reciprocal, it would be 1/4. All right, so keep that in mind. That'll help you with learning target number 10. All right, moving on. Just, I guess, real simple here. Like write an equation of the line that goes through this point and has a slope of -3. Well, there's 3 main ways that we can write formulas, or linear formulas, linear functions. I think this one sets itself up most easily for point slope. We have a point, x1, y1, and we have a slope. And so if you can remember that form, we got y minus 1 equals the slope, -3, times x minus negative, so plus 4. So there is an equation of a line that goes through -4, 1, and has a slope of -3. If I wanted to turn it into slope-intercept form, I could certainly do that. But this is definitely a legitimate function. I don't need to change it unless I'm asked to. So let's go ahead and do the distributive property, subtract 12. Then I could add 1 to both sides, and then I've got y equals -3x minus 11. So I could write it in slope-intercept form. If I wanted to take it one step further, I could take it into standard form. I could just add 3x to both sides, and I'd have 3x plus y equals -11. Now I've got all 3 forms represented. All right, moving on. Getting gradually more complex. It says write an equation of the line that goes through these 2 points, and then write the result in standard form. Well, if I got 2 points, the only way I can really find anything is by using the slope formula. So remember the slope formula, y2 minus y1 over x2 minus x1. So subtract the y's. I'm going to go -4 minus 2. And then if I went that way before, I got to go this way again. So 2 minus -3. This is going to leave me with -6 over 5. So this is my slope, but that doesn't help me in standard form. Don't use slope at all for standard form. So what I could do is I could put it in point slope form. So I could just say something like y minus, and I could use either one of these. I'll use the first one here, but I could pick either one. Y minus 2 equals my slope, -6/5 times x plus 3, which is definitely not standard form. I gotta kind of put the x and the y on both sides if I want to do that. So now I got y minus 2. To use the distributive property, I get a very ugly -6/5 x, and then what's this going to be? -18/5 over here. Well, I don't like those fractions. I'm going to go ahead and just take everything here, multiply through by the least common denominator, conveniently 5. That's going to leave me with 5y minus 10 equals -6 plus 18. All right, fantastic. Let's go ahead and start pushing things around. Although I guess there's supposed to be an x here. Let's go ahead and add the 6x to both sides. So 6x plus 5y. Let's go ahead and subtract, or I guess add the 10 to both sides, and I get 28. And now it's in standard form, like it asked. All right, so there's writing equations. Let's see, writing equation for this, and then graph the line using slope-intercept form. So kind of same concept, except I'm going to just go a slightly different route. So let's see here. Still going to need to find the slope. So 4 minus 1. Oops. So we got the slope is going to be 4 minus 1 over 2 minus 1, which is just going to be 3. And then graph this using slope-intercept form. So let's go ahead and figure out what this would be in slope-intercept form. We could put it in point slope form and then just convert it, or we could use substitution, which is kind of one of my pet favorites. So we could say y equals 3x plus b. We just don't know what the y-intercept is. And then I can just use this as an x and a y coordinate. So 1 equals 3 times 1 plus b. And then I can solve for b, no problem. I get 1 equals 3 plus b, subtract the 3 from both sides, and b equals -2. So in slope-intercept form, if I just take this -2, slide it back in for the b, and I get y equals 3x minus 2. It does say to graph it, which hopefully this isn't a real big deal for you. You got the y-intercept here at -2. I got to rise over my run, 3 over 1, up 3 to the right 1. And there it is. And I'll just go ahead and connect my dots, and I've got my line. All right, moving right along. It says use the graph to write an equation for the line. So here I'm writing an equation from a graph. Basically, I'm just identifying the slope and the y-intercept, and I'm going to put it into that form. So y equals mx plus b. I need to know the slope. I need to know the y-intercept. Both of these things I can take a look at my graph and find. All right, looks like if I'm going by ones here, my y-intercept is 4, check. Slope, let's be careful. Okay, looks like I got another coordinate right here. So I'm going down 1 to the right 3. So down 1, -1 over 3, right 3, +3. Now I put it all back together. So y equals -1/3 x plus 4. All right, now learning target number 11 is use graphs to solve problems. And so I've got a kind of an extra example here for you in that regards. Okay, so it says solve this equation. Oh man, that's a big long equation with lots of graphs. Could we solve this by graphing? Well, obviously, you know, if I had to do this by graphing, I would really only do it by graphing if I had a graphing calculator or a computer or something that I could do the graph with that would make it easier. But as it is, we'll do it by hand. The first one here, the left-hand side, I guess I got the left-hand side and I got the right-hand side. And essentially what's going on is I'm going to break this up and pretend like both of them are just slope-intercept form, like y equals negative 1/3 x plus 4, and then y equals 2/3 x plus 1. It's kind of like I got a system of equations. I'm going to solve it by graphing. So I've already got the one line here, and then y equals 2/3 x plus 1. Well, there's my y-intercept. My slope is 2/3. So up 2 to the right 3. Got another spot there. Your solution is going to be the x value where they cross. The x value where they cross is going to be right here at x equals 3. So the solution to this big equation is just x equals 3. Now obviously I could solve this algebraically, and maybe that'd even be easier. Not this one, but some it might be. So anyhow, that's solving equations by graphing. All right, I believe this is our last thing here. And this is learning target number 10. You've got parallel and perpendicular lines. So if it's parallel to this one, the slopes need to be the same. But it's in standard form. It means I don't really know the slope right off the bat. So I guess what I'm going to have to do is I'm going to have to turn this into slope-intercept form. I'm going to subtract 2x from both sides. And now I've got 5y equals negative 2x plus 4. Divide both sides by 5, and y equals negative 2/5 x plus 4/5. Not really caring too much what the y-intercept is, because the gold right here is just the slope. The slope is negative 2/5. And so with my new equation, I want y equals negative 2/5 x. And then I'll say, if I'm going to use substitution, I'll just say plus b. And I want to go through the point 3, 5. And so x is 3, y is 5. So I got y equals negative 2/5, or not y, 5. 5 is equal to negative 2/3. X is 3, so I'll plug in that there. Now I can solve for b. I get kind of a weird 5 equals negative 6/5 plus b. So if I added, it's essentially 1.2 to both sides. I get b equals 6.2. And so I guess my final answer here is y equals, I'll just go back, use that slope, negative 2/5 x plus 6.2. So there's the method using substitution. Let's go ahead and use maybe a different method, a potentially easier method for this one. Now notice that I've got the same original function in standard form, so the slope-intercept form would still be the same. And even over here, I've got the same coordinate that I'm going through. This time I just want it to be perpendicular. So that means my slope has to be the negative inverse. Well, if I'm starting out with y equals negative 2/5 x plus 4/5, the slope of my new one needs to be the negative inverse of this slope. So negative 2 over 5 goes to positive 5 over 2. And to tell you the truth, point slope form is where it's going to be for this particular one. All I've got to do for point slope is just do y minus 5 equals the slope, 5/2, times x minus 3. And I'm done. Boom. Which was a little bit easier than substitution with the fractions. All right, well, that's it for today. We got the 3 learning targets. And so